Hi guys, welcome back to Savage. What we're on today, we've got still those gearboxes in bits. We were going to do the video about installing the front wheel, but it'll have to wait for a minute. I've got to clean the decks first. We've got lots of gearbox stuff still out for the moment. The bike is finished, so it's running back on a standard ratio gearbox. And our chronometric, it works, is lovely, it works absolutely fine. We've got our interior light working, the mileometer works, and the day tripper works as well. Pleased with that. It was a lot of work to get a speedo working, but yeah, it's great. Before that, we mentioned in the other video, we had a wide ratio box in here for years with the sidecar. It was great with a sidecar, but a standard box is so much nicer to ride, so that's why we converted it back to standard. While we're still on the whole gearbox sketch, because I was not going to do a video about gearboxes, is I've got the wide ratio cluster, and those are the parts. Well, the best thing to do actually is to build up another box, just so all the parts stay together. So we started on it yesterday, and next couple of clips be what we did yesterday. Cleaned out all the holes, all the blind holes, get all the crap out of the threads. Very important to prep it. We also flattened it because there was a weld repair on the other case that we're using. So that's what we're doing, but the box is not complete. That's why it's not a complete gearbox video. We are missing the selector shaft. This is one that I made from the other box. I just pulled it out of the other box for the moment, so I can use it for the dimensions lengthwise. You can get them new, I think you can, but the problem we have with buying new parts is, well, they only make them to the standard size, and they work in conjunction with the other part, in this case the selector forks, and also the fit in the hole in the gearbox, and it's the two parts together that wear out. Now the shaft doesn't wear out, but the holes in the gearbox can suffer. So that's why I like to make them myself, and then we can make them like 500 fatter than what they used to be, and we can make a good fit in the gearbox. Of course, if you buy a standard part, the measurements be standard, so you're only fixing half of the problem. So this one, that's what I made years ago. So there is no play in these whatsoever. You know, I blueprint them basically, you know, just make them to suit to do the job, and you get a better result, and we don't have to wait on the postman. This is my little gearbox stand. As you might have realised from the other video, we make a lot of little tools that make our life easy building these old Triumphs. So this little stand, you can turn it any direction. That makes it easy, like to work on the gearbox. So the first thing we're going to do is, see, I repaired this a few years ago. It's been kicking around for a while. So we're going to pull this dowel out, and we're going to run it over a flat plate for a moment, just to see how flat this is. And you've got to be careful with flattening it, that you still got end clearance between the bushes for your lay shaft, and we'll check that in a minute. Alright, so the first thing we've got to do is get that dowel out, and then we'll just flatten it, or just a couple of strokes, just to see how flat I made this, because I filed this. And it was broken here, so but it's all fixed now. And then after that we'll wash it out, put a new bearing in. That will involve another special tool, the bush rather, yeah, and a bearing. Now in this case I've done one of these before. It's the hole for the selector shaft. It wears out. once it gets a bit of play in it. And so if you buy a new selector shaft, the shaft is a lot stronger because it's steel rather than the aluminium housing, and the play will be in the housing, and then it just gets located in here. There's no cap on it, so if it's not a very good fit, that's one of your potential oil leaks. So what I've done before is make a new selector shaft and make them slightly oversized where they fit, and then you've got a proper fit. Okay, first things first, get this dowel out. There we go. Yeah, before we'll flatten it, we'll clean out the threads. When you're sending cases off to get vapor blasted or whatever, don't expect they'll clean the bottom of the holes. More than likely, it'll put more crap on top. So you need to prepare them yourself before you send them off to vapor blasting, or even if you're just building it up. The amount of crap over the years that gets compounded in the bottom of the hole is unreal. Now, luckily this is a good candidate to show you, because I haven't cleaned these out yet. Best thing what I find to do is use a little drill bit. It's actually 3.5, 4 millimeters would be best for the 1/4 inch holes. Just so it fits loose in the thread, and just wind it in there, and you can feel it. Right. So all the crap that comes out of it, you know, old silicone, just anything. And I'm not at the bottom yet. Yeah, look at it. Look at all that. So yeah, with any blind holes with old cases, it'll have a load of silicone, crap in the bottom. Clean them out. Honestly, I use quite a bit of force. Just force that drill bit down till you feel it spinning smooth, and then you know you cut through the bottom of the crap. I think we're just about there now. And then afterwards, oh, look at that. Yeah. Do this before running a tap through it. Yeah, okay, now it's clean. Oh yeah, now we're hitting the bottom. Let's do another one. Oh yeah, I can feel this right now. Don't do it with a drill, just do it by hand, you know. Look at that. Let's see what we can get out of this one. Look, the drill is just stuck in crap. Look at this. Yeah, look at that. Look at all. Oops, yeah, look at that. Look at all this coming out. And if you don't clean them out, your new screw in, it'll bottom out on the crap. You think it's tight, but it's not tight, and you can strip the threads. So before you go in with a tap, do this first. Otherwise, you'll never get to the bottom. The tap won't get it. There we go. You feel it. Now I'm in the bottom of the hole. I'm on the aluminium. When it goes smooth, you know you're there. if you prepare your holes before you send it off for vapor blasting, then afterwards it's really easy to clean it, you know. If there's oil in the bottom of the medium, we'll just stick in it and it'll be even harder. So if you prepare all your holes and also with vapor blasting, don't expect them to spend 10 minutes on this tiny little speck in this corner here, what is still stuck, yeah. So if you prepare your casings, you know, just scrape it loose, you know, and all the little crooks and crannies. Then when it gets vapor blasted, when it comes back, it's absolutely brilliant, and they won't have missed any small spots, you know. Oh, so that's good. Let's have a look at this one. This is a good example why you need to clean these out, and the tap will just push the dirt further down. So that's why I find it. Look at that. Look at that. It's really compounded in there. If you're unsure, the blind holes they're drilled on a jig borer, they'll all be a very similar depth. So it's not a guarantee, but let's go check that one. That's an open hole. Right, but that was extreme, but it was yeah, a good example of cleaning the holes out. When you run a tap through it in aluminium, don't use a brand new tap. I like to use just an old worn tap, because you don't want to cut any more thread. You just want to clean it out. And also what you can do is a little trick, because the thread's tapped in blind holes because the machine tapped. The tap's got a lead on it, so and also for the tolerances of the machine, the tap won't reach the bottom of the hole most of the time, and it's got a lead on it. So if you've got a thread what is slightly compromised at the front, you can use a bottoming tap. You know, get an old tap, grind the lead of it, so you just sort of got one thread left with a tiny bit of the lead left on it, and then you can tap it slightly deeper and use a slightly longer screw. Sometimes that's a good way if it's difficult to repair the thread. Well, yeah, you might have been able to gain a few threads in the bottom of the hole with a bottoming tap. Sometimes you can put a stud in it, not in this case. A good example of that is the Triumph fork legs with the caps. They are bolts. That front wheel's been in and out 100,000 times, plus it's not so easy sometimes to line the bolts up. You've got the whole wheel. I'll find the bottom threads in the bottom of them legs. Many times they are worn out, you know, and the bolts are worn out. It's not very good for a bolt to come out holding your front wheel on. Them ones, if they are a bit worn out, you can go in there with a bottoming tap, you gain a few more threads and make some studs that screw right into the end, and use some nuts, and that fixes that problem. That's quite a good solution for them, because especially they're user bolts, you know, that wheel's been in and out when each time you change tires and stuff like that, so them threads can suffer. So yeah, go in a bit deeper with a bottoming tap and put some studs in them. Right, so that's that. So yeah, use a worn out tap, or worn out, not a new tap, preferably when you're cleaning threads out. And then another thing, and yeah, this is a good example for this one. This hole here, it's in the casting, hopefully you can see it. It's a through hole there, yeah, but you see that the casting runs like this, yeah, it's not flat at the bottom. You get that many times with threads that pass through a casting. So if you tap a thread in there, or you clean the thread up when it's half open, don't drive the tap in too far, because the thread will be still here on the one side, or sort of on the hill. When you go too deep, it pushes the tap sideways and it'll start cutting more thread on the top and making your hole too big, you know, and, you know, wallowing the thread out. So yeah, be careful with through holes in castings, because it's not supported on the other side. It will start pushing the tap sideways, and you'll start cutting more on the top. Yeah, so that's a good example of that one. If you come across casting holes like that with threading, yeah, don't go too deep, because it'll push the tap that way, and you cut more thread, what you don't want. You want to save all the thread you can, because the threads are old. If you grind the tap down, it'll have a little burr in it. Just get a nut and work your tap. Just get the burr of it off before you go into the soft aluminium, you know. Try to get the tap in without using the holders. Wiggle it. So, especially a bottom tap. There we go. They're a bit hard to line up. There we go. So yeah, like with this one, so he is coming through there. So still a bit of dirt. Don't go. That's it. Don't go too far, because the back is still supported, the front isn't. It'll push the tap over and it'll start cutting on the side here and making an oval thread. Yeah. There we go. So let's stop them done. This one here, should measure the bottom of the hole first. But yeah, sometimes you can gain a few more threads by using a bottom tap, if the hole is deeper than the machine tap went. Now they're clean. We're going to done these two big ones, so that's all good. All right, now I'll quickly flatten it and see where we are here. I think I left this slightly proud with the file, so to just give it a skin on a flat plate. All right, let's go and have a look at that. All right, we're ready to see how flat this is after my weld repair from years ago. Another little thing, just cover it in marker pen, then you see it straight away where it's carrying and where it's not. You can only take ever such a slight bit off because of the end play for the lace shaft bushes, so you watch that. That's why, so long you've got a good flat surface, I mean a really good flat surface, like This was done on a surface grinder. It's an old milling table, but it's been cleaned up on a surface grinder. It's really less than half a thousand, correct. You can just lap it in to take absolute the minimum off. If you were to put this on a milling machine, to take the absolute minimum of it off, it would take considerable time for the engineer to tram it in to take absolute the minimum off. You soon take a few thousandths off, and that's too much. So the easiest thing is to lap it in, so long your table is completely flat. And then another thing worth noting is, before you're getting happy about rebuilding your gearbox, is the state of your bottom mount, you know, the one that runs through the frame. The holes wear out, and if the hole is worn out, it won't hold its chain tension very well. So it is well worth it to check the bolt. It's got to be a nice sliding fit. If it's not, more than likely it will be worn out. Put a sleeve in it, you know, get it to an engineer, put it on a milling machine, ream it out, put a sleeve in it. Or you can, because what happens sometimes as well, because you never know what life they had, these old things, sometimes they have been altered for, like, put them into like specials with homemade engine plates and stuff like that. So sometimes it's not the correct dimension anymore. And the width of it is very important if you put it back in an original frame. You get the seat post coming down, and it's the same for the rigid or for the swing and arm frames. You get the seat post coming down, and there is another support just in front of it. The two tubes where the bosses are for the bolt, they will not move when you tighten the bolt up ever so slightly. They're very stiff because they're supported before and aft by other parts. So if the distance here is not correct, it will not clamp up. And if it doesn't clamp up, you put too much strain on your top mount, and you're having problems with keeping your chain tension under control. So it's important take the paint off of the inside on your frame. The paint will wear off anyway. So take the paint off and measure the distance exactly correct, and then make this distance like it is literally a sliding fit. It wants to be difficult sticking it in there, and remachine it. What you can do if you take, because you don't know which side is worn off more, so what you can do if you take it to an engineer shop, because you need to have the position correct as well, is ream it out and ask him to counterbore it, spot face it, put a spot in here, take it down by 1/4 of an inch or less, an eighth say. Do the same on that side, and then if you've got a lathe at home, you can make 2 top hat inserts that press in. And then you can at home play around with your little top hats to get the positioning exactly correct. And if you get it wrong, you can just make a new top hat for it. And that will reinforce it till to be better as in the factory. Yeah, so you can see this one here is that won't hold properly, you know, because like I say, the frame is very stiff here. It hardly pinches together. You want about 1/1000 clearance. It will nip up 1/1000 or 2/1000, but not much more than that. So the distance here, the width, is just as crucial as the size of the hole. If it can, that's my motto. If it can move a slight bit, it can move more, and it'll wallow out. And there is a point where your tolerances are so nice that it won't start moving, and if it won't start moving then it can't wear out and it'll stay put where it is. All right, let's have a look how flat this is. Yeah, only do it when you've got something that is absolutely perfectly flat. Put a bit of lube on it. When you start with a fresh piece of this is a 600 grit. When you start with a fresh paper, sandpaper, you've got to break the sandpaper in and go all over with it lightly for the beginning. Otherwise, if you just start in the middle, each time you venture out to the side, it'll sand more on the side than it does in the middle where your paper has been broken down. So you have to sort of work your paper in a little bit. Because otherwise it'll stick when you get to a fresh piece. No. Right, we're as good as there. It didn't take long at all. The tiny little spot there. I wouldn't worry about it too much. Do a little bit more and then it's done. You can do it so long as you don't feel any rock. A cylinder head would be a lot more difficult because it's narrow. Once you start having a bit of rock in it, it is really hard to recover from it. You have to keep it flat. But the base here, it is quite wide, so yeah, it's quite supported. So I'm quite confident that it's quite good. Right. Yeah, tiniest little bit there. I wouldn't worry about it. Maybe yes. Yeah. I'm not going to bother about that last little bit. That's fine. Be careful, not take too much off for the end play of the shaft. I ran these over it very briefly. Yeah, they are flat. They've got a couple of nicks in them, but yeah, they are flat as they are. So let's give it. You've got to take the bush out when you do this side because the bush sits slightly proud of the face. That's at the top, so I'm not worried about it. Don't want to take too much off. Just carry on all the way around. I might do that side a little bit more. Let's see. I decided so I got a little badge sticking out. Yeah, it's good to go. I'll do. That'll do for that. Because I've, you can see him. I've got a hungry cat there who wants his dinner. Where is he? You want your dinner? And I got to make a bracket for my speedo cable and go for a beer and go and test my speedo out. Alright, let's make the bracket now and we're done for today. Alright, carry on tomorrow. Bye bye.